So the second part is related with the task interdependence, the theory of James D. Thompson. Basically, in this portion, we talk about the task interdependence. What does it mean is the manner in which different organizational tasks are related to one another. In this context, the Woodward focused on how an organization's technology affects its choice of structure. Paro's model of technology focuses on the way in which the complexity of task affects organizational structure. And then when task interdependence is low, people and departments are individually specialized. This means that there is no dependence and the people are doing their job through their own specialization and managing the work with respect to their concerned departments and has the expertise to manage it properly. That is, they work separately and independently to achieve organizational goals. When task interdependence is high, people and departments are giantly specialized and they work together for a particular project or for a task. You can say that is, they depend on one another for supplying the inputs and resources they need to get the work done. You can say that manufacturing organization is most probably are the interdependent organizations and people are gently specialized. One unit has the one specific expertise and the other unit has the other particular expertise. Thompson identified the three types of technology: mediating, long linked, and intensive. What does it this means is the mediating technology and pooled interdependence are technology characterized by a work process in which input conversion and output activities can performed independently of one another. Mediating technology is characterized by a work process in which input conversion and output activities can be performed independently of one another. Mediating technology is based on pool task interdependence, which means that each part of the organization, whether a person, team, or department, contributes separately to the performance of the whole organization. So here we can say that if we go further, if we further analyze this thing as the 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 task interdependence and three types of technology is that type of technology is basically linked with mediating, long linked, and intensive. In a mediating, we have a pooled in which you can say that X, Y, Z, that is a piecework or franchise, you can say that. And sequential is when we're talking about the long linked, so we talk about sequential. By sequential, we means to say that assembly line or continuous process plant, you can say that. It means that when one thing happened, this goes to the another, and the second thing happened, this goes to the third thing. That it means that X, Y, and Z as a symmetry is a you can say that in horizontal if you draw it. So X, 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 and then this leads to Y, and then Y leads to Z. This means that an assembly line, you can say that it's assembly line or a continuous process. First thing happened, which is related with the X. Second thing happened, which is related with Y. And the third thing happened that is related with the Z or Z. Intensive is reciprocal, is basically that is a journal, hospital, or research and development laboratory because they are interconnected with each other. So by the interconnected with each other, they are talking that we have the form of interdependence is related with the reciprocal. So the type of technology is mediating. The task of interdependence is pooled. The second one is long linked, and then the task of interdependence in the long linked is sequential, and intensive is reciprocal. So the type of technology is intensive, and the task of interdependence is reciprocal. So the other thing is that how we coordinate, when we're talking about a pooled structure, that piecework or franchise, we need the standardization. The type of coordination in mediation is standardization. The type of coordination is in the technology of long linked is planning and scheduling. And the last one is the intensive is the type of coordination is mutual adjustment. You can say that because they both the system is interdependent on each other, so are reciprocal to each other. So this is basically work best when mutual adjustment is work together. Okay. Then long linked is the second type of technology that Thomson identified is based on a work process where input, conversion, and output activities must performed in series. Long linked technology is based on sequential task interdependence, which means that the actions of one person or dependent department directly affect the actions of another. So work cannot be successfully completed by allowing each person or department to operate independently. So this is assembly line. So every single department is working on their own. Other thing is the slack resources. What does it mean is we can say that extra surplus resources that enhances its organization's ability to deal with unexpected situation. For example, a mass production organization stockpiles inputs and holds inventories of component parts so the conversion process is not disrupted if there is a problem with the suppliers. Intensive technology and reciprocal interdependence. I explained it to you. Intensive technology is the third type of technology Thomson identifies is characterized by a work process where input, conversion, and output activities are inseparable. Intensive technology is based on reciprocal task interdependence, which means that the activities of all people and all departments fully depend on one another. Not only do X actions affect what Y and Z can do, but the actions of Z also affects Y's and X performance. This means that it's reciprocal. So they all together working together, and they can reciprocate the actions of the others unit as well. The task relationships of XYZ are reciprocally interdependent. Hospitals are organizations that operate an intensive technology. Hospitals' greatest source of uncertainty is the impossibility of predicting the types of problems for which patients' clients will seek treatment. The other thing is the advanced manufacturing technology, innovations in the material technology. Material technology comprises machinery, other equipments, and computers. Innovations in material technology are based on a new view of the linkages among input, conversion, and output activities. Traditional mass production tries to protect the conversion process from disruptions at the input and output stages by using stockpiles of inventory as buffers to increase control and reduce uncertainty. Computer aided design is mass production systems are set to produce a large quantity of few products. To some degree, this arrangement reflects the fact that a large part of the cost associated with mass production is incurred at the design stage. In general, the more complex a product, the higher the design cost. The cost of designing a new car, for example, are enormous. Ford's recent world car, the Focus, cost over 15 billion to develop. Well, this is a computer-aided programs, a computer-aided design based on the computer and dependent on the computers. Computer-aided materials management, CAMM, is an advanced manufacturing technique used to manage the flow of raw materials and component parts into the conversion process to develop master's production schedules for manufacturing and to control inventory. The difference between traditional material management and the new computer-aided technique is the difference between so-called push and pull approaches to material management. Traditional mass production uses the push approach, Materials are released from the input to the conversion stage when the production control system indicates that the conversion stage is ready to receive them. The inputs are pushed into the conversion process in accordance with the previously determined plan. Now, computer-aided material management makes possible to the pull approach. The flow of input material is governed by customer's request for supply of the finished products. So the inputs are pulled into the conversion process in response to a pull from the output stage rather than a push from the input stage. Just in time inventory system is another thing is when we is focusing on the other part of the discussions. So uh, just in time is basically let me explain it to you in a different way. Just in time is basically related when, for example, the activities are work from customers making purchases. If, for example, customers buys product, this leads to the store, orders more product from manufacturer signals supplier, then makes product to meet stores order, and then this leads to supplies, signal their suppliers and produce to meet manufacturers orders, other suppliers, and so on. This is just an in-time system that increases the task interdependence between stages in the production change, and traditional mass production draws a boundary between the conversion stage and the input and output stages and sequences conversion activities only. Just in time is basically system break down these barriers and make the whole value creation process a single chain of sequential activities. Because organizational activities become a continuous process, technical complexity increases, in turn increases the efficiency of the system, and at the same time, just in time system brings flexibility to manufacturing, the ability to order components as they are needed allows an organizations to widen the range of the product makes it. So this is a just-in-time inventory, and then we components are kept in bins, and as they are used up, the empty bins are sent back to the supplier with a request on the bins card Kanban for more components. Computer-aided materials management system. Material management is necessary for JIT system to work effectively because CAMM provides computerized linkages with suppliers. CAM is basically computer-aided materials management. We can say that computer-aided material management is necessary for JIT system to work effectively because CAMM provides computerized linkage with suppliers, linkages that facilitate the rapid transfer of information and coordination between an organization and its suppliers. Flexible manufacturing technology, by contrast, allows the production of many kinds of components at little or no extra cost on the same machine. Each machine in a flexible manufacturing system is able to perform a range of different operations, and the machines in sequence are able to vary their operations so a wide variety of different components can be produced. Flexible manufacturing technology combines the variety advantage of small batch production with the low cost advantage of a continuous process production. Computerized in integrated manufacturing is an advanced manufacturing technique that control the change over from one operations to another by means of the commands given to the machines through computer software. Now, when we're talking about this, how this achieved is basically in a flexible manufacturing system, the key factor that prevents the cost increases associated with changing operations is the use of a computer control system to manage operations. So the computer manage or the computer control system to manage operation is relatively related with the flexible manufacturing technology. So this basically control the production process and manage the low cost advantages and given the low cost advantages in the batch production. And the computer integrated manufacturing is an advanced manufacturing technique that controls the changeover from one operations to another by means of the command given to the machines through computer software. So computer software is basically controlled, and this makes the flexible manufacturing technology works together and make the organizations more effective and related with towards the outcome. So one thing is the JIT, just in time inventory, that it's related with each other. And the other thing is the flexible manufacturing technology. And the flexible manufacturing technology. And then the last part is computer integrated manufacturing, as we has the focused on it. The other thing is nowadays the use of robots is integral to CIM, computer integrated manufacturing. A group of robots working in a sequence is basically work related with when you're talking about the technology and when you're talking about the work system in the organization. So these are the factors related it. And then dedicated transfer machines. Each robot can be quickly programmed by software to perform different operations, and the cost of the of reprogramming robots are much lower than cost associated with retooling dedicated transfer machines. So these are major things which we can say that in reference to these area or in reference to the flexible manufacturing technology. What we studied in this chapter is the technology is the combination of skills, knowledge, as we discussed. Then the technology is involved in organization input, conversion, and output. Technological complexity is the extent to which a production process is controllable and predictable. Woodward is argued that each technology is associated with a different organizational structure because each technology presents different control and coordination problems. Other than the part we highlight the three types of technology which he associated with three forms of task interdependence, mediating technology, and pool interdependence. Earlier explained it to you in a very detailed manner, and you already have listened the things. And if you have any questions, then we can discuss the same, and we can discuss the same portion in the group as well. And you have any question, I am giving you a task related with the organizational theory, choosing a technology. So that is related, that will be available in your LMS and you have to complete it. This is your class task with reference to this lecture. So thank you very much and have good time. This end my this part of the chapter, and this concludes our chapter number 9 related with the technology. Thank you very much.